Hello everyone, today I will share how to use the Gaussian model to create particle effects. First, let us take a look at the final effect. First, import our Gaussian scene. The cube border that wraps the scene is actually a cropping box. We can use it to crop our scene. We can choose to keep the Gaussian points within the border or the Gaussian points outside the border. At the same time, after cropping, we can use these points to create special effects. For example, when I click the Crop Gaussian Points button, it will form a corresponding Niagara particle system, which will only contain the remaining Gaussian points. Since our special effect requires the entire scene, we first enlarge our cropping frame so that it wraps the entire scene. Then click the Crop button. In this way, it will form a Niagara particle system in the corresponding directory. Then we can create special effects based on this particle system. First, set the position of the particle and return it to the coordinate origin and then add a camera. I'm using a location I found before. Then we adjust his focal length. Let's add a level sequence. Drag both the camera and particles into the level sequence. And set them to spawnable mode. Since we don't need to dynamically modify the camera's properties, we can delete the track of the camera component. Similarly, we don't need to modify the position of the Niagara object, so we can delete the transform track of the Niagara object. In order to prevent us from accidentally modifying the camera's position, we can give the camera's transform track K a keyframe. This way, even if we modify the camera's position, it can return to its original position when sliding the keyframe. Next, we officially start to do the particle effect. The goal we want to achieve in the first stage is a color diffusion effect. You can see the result from this animation. First, we create a Niagara expression asset. Rename him. Then open our particle system. We need to make some modifications to it. For example, we don't need this volume clipping module. Then the module for sampling the texture can be placed on top, because in this case, it only needs to be sampled once. The second step is to drag our Niagara expression asset into our launcher. First, we create a user parameter of floating point type. Then name it mask color. Then we enter our module and need to import two attributes. One is the particle color. One is the coordinate of the particle. Particle color, we need to set it to initial. Then we add an input floating point attribute. Let's name it mask color. Then use the coordinates of the particles to calculate the distance. We specify a coordinate. It will calculate the distance between the coordinates of each particle and the specified coordinates. The coordinates specified here are actually the point on the table in our scene. All effects will be centered on this point and spread to all directions. Then we remap the distance. Add the result of the map to our input properties. This input attribute will then be animated in the level sequence. In this case, you will get a dynamic mask. Here we judge the result of the addition. If the result is greater than 0, then output 1, otherwise output 0. This way we can get a black or white mask. You can see the effect of masking in this animation. Then we remap the result of the addition. Then multiply the previous mask and the remapped result to get a new mask. You can see the effect of this new mask in this animation. Then we use this new mask to blend the two colors. The first color is pure white. Choose a bright yellow for the second color. Then multiply our initial particle color by the color we mixed. Then output the color to the particles. At the same time, we output two more particle attributes to facilitate controlling the size of the particles later. Then we remap here. The output is the second particle attribute. Return to our Niagara interface. Bind user parameters to our module input. Then go to the level sequence. Add our Niagara component and add a track to our user parameters. Then animate it. The number of frames of the specific animation depends on the effect. You should be able to see the color diffusion effect when we play it. Next, we deal with the size attributes of the particles. We can see from this animation the effect we want to present at this stage. First, we create a Niagara expression asset. Then add the asset to the emitter. Access our assets. We need to add a few properties. Particle distance ramp is what we output in the previous module. It's the distance of each particle to the specified coordinates, and then we remap it to the range of 0 to -1. We add it to mask size. Afterwards, we will perform K animation processing on mask size in the level sequence to obtain a dynamic mask. We can visualize this mask in this animation. Limit the result of addition to the range 0到1。Then multiply by 0.05。Multiply the size of the particle by the result of our calculation and output it as the size of the particle. The reason why we need to multiply it by 0.05 here is because the scaling effect of our particles is divided into two stages. The first stage is to enlarge the particle size from 0 to 0.05. The second stage is to enlarge the particle size from 0.05 to 1. We can see the two stages from the above animation. Return to particle interface. Find the properties of the particles. Then we add a new user parameter. Bind it to the input of our module. Then we animate the mask size attribute K. So we can see the zoom effect of the first layer. Then we start making the second layer of zoom effect. We use mask color R to mix values from 0 to 1-0.05. Then add it to the scale effect of the first layer. Mask color R is the result we output in the previous module. It is the result of this remapping. We can see the effect of this mask color R in the animation. Return to the main interface and play directly to see the two-layer zoom effect. Next, we start to create the effect of particle dissipation. The effect we hope to achieve in this step is as follows. First, we create a Niagara expression asset. Add assets to emitter. We need to add a few properties. Multiply the size of the particle by the mask dissipate and then output it to the size of the particle. Let us first change the channel of the particle color to 0. Then use mask color send to mix the original particle color with a color with transparency of 0 and then output the color to the particles. Let us add a few user parameters. Then associate it to the input of the module. Go to the level sequence to add animations to user parameters. Now we can see the effect of the particles gradually getting smaller and disappearing, but there is no change in transparency yet. We need to modify the material. First, we copy the material that comes with the plugin. If you cannot see the plugin content, you can click to open it in the settings to display plugin content. Then we make a copy of this material. Then we simply modify the material to multiply the output of the transparency channel of the material by the channel of the particle. Then output to transparency. Then we assign the material to our particles. Now our particles have transparency changes when they disappear. However, the change in transparency is not very drastic. If you want the transparency to change significantly, you can change this value to 1. Next, we create the effect of particles flying. We can preview the effect in this animation. Return to particle interface. We need to add the particle modules. It is necessary to pay attention to the placement order of these 4 modules. The particle state is placed at the front, then the wind force, then the resistance, then the solution force and speed. Sometimes, if the order of the modules is wrong, it will cause errors in the particles. Then we make some settings for the module. First, uncheck kill particles. Then adjust the wind parameters. Let's add another user parameter. Connect it to our wind power. Then we animate the wind K in the level sequence. When we play the level sequence, we will find that the position of our particles has shifted. That is because we added wind force to the particles. So when we replay, we need to click to restore the animation state of the particles. Finally, we can add a post-processing for later color grading.